Hi, I'd like to talk about design for reliability. Reliability is the probability that a system delivers its required performance over a defined period of time. Durability is about building a product to resist degradation and failure, which contributes to reliability. But there's always uncertainty in how the product will be used, uncertainty in the operating conditions, and even uncertainty about how the damage may accumulate. And so reliability is all about risk. Risk, of course, is the probability that there's some adverse event that happens, multiplied by the cost of the consequences of that event. Risk depends on the circumstances. For example, crossing the street has a risk. This unconditional risk covers all of the possible risk scenarios associated with crossing the street. As such, it's not a very useful risk description. Instead, it would be more useful to know the risk associated with crossing the street when there is no traffic, when there is traffic, when there's traffic at night, and so on. In design, we need to understand the possible ways that our system might fail to deliver performance. Fault modes and effects analysis, or FMEA, is a structured method for identifying failure modes, their risks, and how various controls such as design changes can control the risk to an acceptable level. Cut sets allow us to see whether failure of a single system element would lead to system functional failure. Risk models allow us to look at combinations of circumstances and failure modes to assess the risk of not delivering the required performance. Improving durability reduces the probability of failure over a period of time, and so designing for durability is an important approach for improving system reliability. While quantitative risk models can be built, we generally do not have enough information about the conditional probabilities of failure or the variability of loading conditions and external factors. In that case, we can state assumptions about the likelihood of our possible failures, and we can ask our client's opinion as a person with knowledge of the application area. For Phase 2 conceptual design, it's usual and good enough to identify and rank the failure modes that would lead to a complete system failure, and put in some risk controls such as stronger, tougher machine elements with higher factor of safety, or higher quality components such as batteries that have more charge capacity when it's cold, that kind of thing. In that way, we're building in contingency to reduce the probability of failure. This is okay during Phase 2, but in Phase 3, the detailed design should characterize the uncertainties as well as possible, such that loading conditions are better understood, and so factors of safety don't have to be excessively conservative. Next week, we'll discuss how to put conceptual models together and what might be important in evaluating them to choose which design to take forward to Phase 3.